Hello everyone, my name is Oscar Finneran and today I will be presenting my capstone project for my CIA 2300C class. My project is titled Sentimental Analysis of Customer Reviews using TF-IDF and Machine Learning. In this presentation, I'll walk you through the dataset, the NLP model I selected, as well as how it works and how it can be applied in real-world scenarios. I hope you enjoy this presentation and sit tight. The problem I chose to address is sentiment analysis. Specifically, I wanted to automatically classify customer reviews as either positive or negative. This is important because businesses review thousands of reviews and manually analyzing them takes a lot of time. By using a natural language processing, we can automate this process and quickly gain insight into customer satisfaction. In this slide, I also wanted to implement why does a natural language processes matter with data-driven business decision, consistent classification standards, scalable processing, and large dataset and real-time feedback analysis. For this project, I used the Yelp review dataset from Kaggle. This dataset contains real customer reviews along with sentimental labels, which makes it ideal for classification tasks. The structure includes text data such as reviews content and corresponding labels indicating where the sentiment is positive or negative. I chose this dataset because it is large, realistic, and commonly used for natural language processing tasks, making it a strong fit for the sentiment analysis dataset. As for the Yelp reviews, it's for restaurants, businesses with star rating, and all the business information. Amazon reviews for product reviews, as well as their star ratings and customers, as well as the seller's information. And Kaggle source is publicly available, as well as a well-documented data set. And it has over 100,000 reviews with the diverse vocabulary, real-world language patterns, and clear positive and negative labels. Okay. So how did I manage to do this? Well, I downloaded the dataset from Kaggle and prepared it for analysis. This involved several pre-processing steps, including converting all text to lowercase, removing punctuation, and eliminating common stop words like the and end. These steps help clean the data and improve model performance, as well as optimize it for the best performance that I needed. From an ethical perspective, this dataset is publicly available and does not include personally identifiable information, so it's safe for use. In addition to that, I wanted to make sure I have it's set up in a way that is best optimizable and does not include so many bias. So as for the dataset exploration, during my exploration, I observed that the dataset contains a large vocabulary ranging from about 10,000 to 50,000 unique words. Reviews lengths vary significantly based on the user that inputted them, as well as the star rating. The review vary from short comments to longer detailed feedbacks with images and sometimes videos included. This is also noise in the data, including typos, slang, and informal language that some new millennials or Gen Z input as for their reviews. For example, a positive review might say that the food was amazing and that the service was great. This is a good formatted review. Understanding these characteristics is very important for building an effective natural language processing NLP model. As for our noise, we want to make sure that it's as low possible to make sure that we use casual language and try to minimize the use of symbols, emojis, or any other additional settings. So what we're gonna do is we're gonna uh, cut those from our reviews and input it as lowercase content into our process. As we continue, this is the core methodology. So for my approach, I use the TF-IDF vectorization combined with logical regression classifiers. So the TF-IDF converts text into numerical values, as we talked in class how to do that, and how important each word is within the document and across the data set. So this is the TF frequency right here. Then documented frequency is going to be under DF. So it goes right over here. So how many documents contain the world, and then inverse weighting. So the rare words take higher importance scores. On our example that we did in class, it was on a table, and in the homework we had to pick based on the documents and use the words that were rare or in higher importance scores. I selected this method because it is simply efficient and performs well for text classification tasks, as well as it also provides interpretability, allowing us to understand which words influence predictions, as well as which words are highly efficient for our documentation. Yep. Let's continue. As for our model architecture pipeline, so this model allows a straightforward pipeline. First, the text is tokenized into internal words. There we go. So we had raw text that turns into tokenization. Next, the TF-IDF transformed the text into numerical vectors. So we're gonna go right here then. Then those vectors are passed into logical regression models, which predict whether the sentiment is positive or negative. So it learns the whole classification patterns. And then finally, the model outputs the classification results, which will be our predictions. Either it's positive or negative. Okay. Then for our training and evaluations. So to evaluate the model, I use standard classification metrics, including accuracy, precision, recall, and F1 scores. Accuracy measures overall correctness, while precision and recall focused on how well the model handled the positive and negative predictions. So I wanted to make sure that the models were accurate, precise, and how the recall actually happened. So in addition, we also had balancing precision, and so precisely almost 85 to 90% of it typically achieve 80 to 95% accuracy, which is really good for those kind of models. So this is how to calculate the F1 score in addition to that. As we continue, I wanted to definitely include model interpretation. So this model learns to associate certain words with sentiment. For example, words like great and excellence are strong indicator of positive settlement, while words like bad or terrible indicate negative sentiments. We use those for positive and negative reviews that help us identify if the user wrote a negative or a positive review. However, the model can struggle with more complex language patterns such as sarcasm or mixed sentiment with a single review. Those cases highlight our limitations of simpler and natural language processing models. So for positive, we have great, excellent, awesome, and perfect. And then for negative, we have bad, terrible, awful, worst. And then we can also include excellent, positive, superb, and to the positive. For negative, terrible, awful, the worst, bad, absolutely horrible, to make sure that the model understands it. As for the common errors, sarcasm detection, mixed settlement, and context dependency. Yep. As for the ethical consideration, there are several ethical considerations when working with natural language processing units. First, bias in the training data can affect predictions. That is sadly the reality that the reviews can be our bias that the model will learn upon. So we have to make sure that our reviews are correct. As for the second, incorrect classification could lead to misleading insight for business. So false positives, negatives can impact business decision and customer relationships. We want to make sure that any positive reviews are actually positive reviews. If they're negative, let's stay for the negative to make sure how we can improve. As for the third, there's also a risk for over relying on AI without human verification. As I said, we want to make sure that human judgment and human implementations is always there, so we can guide the model into a better understanding, as well as a successful business owner, we can definitely implement it as an assisting tool on our process. Finally, even though this data set is public, privacy should always be considered when working with text data. So we want to make sure that our privacy, we have transparency, how we're using the data, and that the user, the information that we're collecting from our reviews is going to get stored as our data on the model. So as for real world implementations, so we use customer service automation for automated response route, ticketing efficiency, and prioritize urgent customer issues. For brand monitoring, we want to make sure to track public perceptions as well as our reviews. Recommendation systems, just like Amazon and Yelp, it's going to help you get more reviews as well as more suggestions to your users. For example, your number one pick is going to get recommended if you purchase a drink with it, or have maybe you would like to implement this. This is what most customers choose with it as well. And product improvement. So we're gonna pinpoint popular frequent requests, uncover quality issues, and address customer pain point directly. So we want to make sure that everything is handled or with great feedback. Yep. There we go. Limitations and future improvements. I would say despite its effectiveness, the model has some limitations. Sadly, it struggles with understanding sarcasm and deeper content. It also relies heavily on word frequency rather than meaning. So as for sarcasm, great, just what I needed. Limited contents awareness, sadly. To improve the model, future work could involve using more advanced models like transformers such as BERT, which better understanding content. Additionally, expanding the dataset could further improve